Yesterday, we learned how to calculate a least squares regression line on our calculators, and we also learned how to use the residual plot to make sure that the line is the best model for the data. Today, we'd like to look at a couple of different ways to assess how well that line actually models the data. And the first thing we'll use is the standard deviation of the residuals. So don't forget that a residual gives us the variation of each individual data point from the line. So what we would like to do is just see what an average distance from the line is. So as you can see here, this formula is very similar to what we've done in the past, where we're summing the residuals and then we're dividing by not just n, and actually we're summing the squares of the residuals, and we're not dividing by n, we're dividing by n minus 2, and there is a reason for that. We'll talk about that more later on. And then taking the square root of that. So this value gives us the approximate size of a typical prediction error. And I think it'll help us to just look at an example for that. So as an example, let's look at the Ford F-150 data that we had from an earlier example. In that problem, the S is $5,740. Let's look at how we'll interpret that value in the context of the problem. And it may help you to remember that the explanatory variable was the number of miles driven for a used F-150, and the response variable was the price. And here's how we will interpret S. When using the LSRL to predict the price of a Ford F-150 using the number of miles driven our predictions will typically be off by about $5,740. Okay. All right, we'll talk about that more in class if you're confused about it. And let's look at one more way to assess how well the line fits the data. And this is called the coefficient of determination. So it's a numerical quantity that predicts, that tells us how well the least squares regression line predicts values of the response variable. And what R-squared is going to do is give us the fraction of the variation in the values of y that's accounted for by the least squares regression line. Now, we won't have to calculate this ever. Our calculators will do it for us. But you know how we've always looked at the correlation coefficient, the R. This is literally the R-squared, but it will be given to us on our calculators. And it just tells us how much better the least squares regression line does at predicting values of y than simply guessing the mean y value for every single value of the explanatory variable. Again, I think it will help us to look at an example. So back to the Ford F-150 data, what if the R-squared is 0.664? How will we interpret this in context? We'll say that 66.4% of the variation in price of a Ford F-150 is accounted for by the linear model relating price to miles driven. So what we'll say is the rest of the variation in that price is accounted for by something else besides the miles driven. Maybe the age of the truck or the condition of the truck or something that we haven't even thought about. So again, we'll talk about this more in class and help you understand exactly the interpretation for this. And you'll never have to calculate the S or the R square by hand. It'll all be done on your calculator.